and PG. uh, He has published more than 60 research publications in national and in international repute journals, 30 extension articles, 10 book chapters, 20 booklets. And he has also guided one PhD student, co-guided 3 PhD students, and he is the chairman of 14 MSc veterinary science students and co-guided to 25 MSc veterinary science students. He has handled 5 research projects funded by ICR and Government of Odisha. He has served as a member of different high-level committees of Government of Odisha as well as in the university. He contributed to Central Library OUAT as chief librarian and PIE IDPE NAHEB as chairman of CAS committee of this university. His contribution as a subject matter specialist LPM in ICR committee of BSMA for development of course curriculum in PG and PhD programs has been commendable. He has also contributed immensely as a reviewer to different journals like Indian Journal of Animal Science and Animal Nutrition and Feed Technology, Indian Journal of Animal Production and Pantnagar Journal of Research. He has been awarded with National Fellow of Indian Society of Animal Production and Management, National Fellow of Indian Society of Poultry Science Association, and National Fellow in Animal Nutrition in Association during 2022. He has visited International Livestock Research Institute, Nairobi, Kenya during 2023 for advanced research in sustainable livestock production system in topics. Now I invite Professor Panigrahi to deliver his talk in this 21 days training program. Sir, please.
Thank you, Dr. Sahu and Dr. Parag and Madam. So I welcome you all to this 21 days training program, to my presentation. Thank you for your elaborate description about myself. So the topic assigned to me is rice-based farming system with a dog-cum-fish culture. So I will share my experiences and some of the subjects proper in relation to the topic. So whenever we talk of a farming system, the most important is why we are talking of a farming system. Because as you know, our country with vast agro-diversity, 15 agroclimatic zones, and there is a climate change. So we always talk about food, but we forget about nutritional security. Now, nutritional security has been adjoined with food requirement. As you know, there is a shrinkage of land holding. If you will consider from 1950-51 till date, there is a drastic change in this land holding pattern because there is a division of Hindu families. So there is a fragmented land holdings and there is no expansion horizontally because we cannot increase the land area. So we have to think about, you know, rice monocropping system has a lot of disadvantages. We cannot rely on that. That is not at all sustainable. So let us start with our presentation. So as you know, farming system is definitely a complex matrix. We require soil, we require plants, we require animals, implements, power, labor, capital. Some is being contributed to the farming families. Some is being contributed to various degrees by political, economical, institutional, and social forces, which operate at many levels. So why this farming system? Why integrated farming system? So as you know, integrated farming system is the model. It is a system within the system. It provides sustainability. So nowadays, this sustainability is very important. Sustainability exact meaning is it goes without fail. It may not increase, but there should not be decrease in the production level. There should not be decrease in the yield, because we have to feed 146 crore human population. We have to feed large livestock population. We have to feed large aquatic animals. So sustainability is very important. To get sustainability, this is the only solution, is the integrated farming system. So next is, this provides a system, way of livelihood. The farming community requires a livelihood option. What are the options before the farmers, before the farming community? What best option we can suggest for a farmer, considering the farming community of different localities, different agroclimatic conditions, different agroclimatic situations. So as you know, livelihood is defined as a way of life which requires water, which requires food, fodder, medicine, shelter, and clothing. All these necessities, essentialities, the farmer requires a option, livelihood option, what best we can provide to the farmer. Now we are having lot of data. Our country is data rich, but we are very poor with information. That is true. Whether it is a scientist, whether it is a professor, whether it is a planning personnel, any government sectors, anyway. Lot of data are there. But what information we are having? We have to think of it. We have to analyze it. Meticulously we have to plan. Unless otherwise the information is ready in hand, we cannot have a plan. Scientific planning requires data, requires information. So what are the past experience? Then we have to gather all those informations, all those experiences, then put into critical analysis. What best alternatives we can think of, so that we can have a future plan to see what best management or best methodology can be adopted to meet the requirement, to meet the need. So let us see what are the information where and what more is required. So as you know, we are having the geographical area of 328.7 million hectares. That is a 2.4 geographical area, 7th largest country in the land area. But you see, out of 328, less than half is total agricultural land area, 180 million. Net sown area, current fallow land, total cropped area, and the most important, you just see the last one, the per capita land availability. This is agricultural land. This is not a total land. I am not discussing about it's a homestead where the farmer is staying. I am discussing what net the agricultural land is available for its cultivation. Just see where we are. From 0.48 hectare per ability, we have reached now it's a 0.10 hectare, and further forecast by 2035, it will come down to 0.08 hectare. So with that condition, we have to think what best opportunities are there. This much of land area supports 146 crore human population, that represents 17.78% of world population. 70% depend on agriculture, with 82% farmers being small and marginal. And their contribution is large enough. India's agriculture production. So besides human, just to see 535 million livestock, which represents 15% of the total livestock. 851 million poultry population. All these living organisms require food. So we have to think of quantitatively and qualitatively. Then this much of a poultry, they account second in egg production, fifth in poultry meat production, 1/3 gross national products comes from agriculture sector, but agriculture and the allied sector contributes 18% GDP, and that is in a decreasing trend. That is not in increasing trend. So out of that, livestock sector provides 1/4 of this agricultural GDP. So most importantly, about livestock, agriculture and the fishery sector, highest growth rate is in fishery sector, and a lot of contribution is from livestock. 25.6% agriculture GDP is being contributed from this livestock sector. So that is why we have to incorporate agriculture, livestock, fishery, combining these three enterprises, have an integrated farming system model. So this is our recommendation, Indian Council of Medical Research, National Institute of Nutrition, recommendation my plate for the day. What we are, how much we must take production, no doubt, with the cereal grains, and with the pulses and oil seeds. And total energy intake, we are surplus. And major is being contributed from cereals. But we have to think of the pulses. Protein is highly required, as you know, but we are deficient. So the calorie intake is covered up by the cereals, not by the proteins. So protein, energy from the protein must be provided about 15%, but we are in the stage of 6 to 9%. Half of the energy is coming from this protein. Think of how to increase this pulses production. Regarding animal produce or animal product, we are self-sufficient with milk production. Number one in the world in milk production. That's why you just imagine, you just see what is the per capita availability and what is the recommendation by ICMR. ICMR recommendation is 280 grams per day. We are at a 400, so far ahead. But we are deficient with the egg and meat. The requirement is 182 eggs per year for adult healthy human being. But we are getting only 103 eggs. So still 50% is from kg per year, we are at a 7. Regarding fish, we require 12 kg per year, but we are at 6 kg per year. But as this fishery sector is having highest growth rate, we can reach this much figure very shortly. Now, what are the challenges? As for a few minutes, we are self-sufficient in food grains, but we are suffering from malnutrition. The malnutrition, nutritionally balanced feed is not available to the human beings. You live about livestock. Every third child born in the malnourished, and 45% of the children below the age of 3 years are malnourished. So we have to see how to cope up these deficiencies. Water and energy securities are, we require water, we require energy. But for water, just you see what is the major problem. There is a groundwater, major concern. And the water table in the country is dipping every year by 0.4 meter. And you see the water availability, per capita water availability. Just have a comparison. 1951 forecast by 2050 and 2025 where we are and forecast. The population will be increased, water availability, per capita water availability, and 7 cubic meter, it comes down to 1,140. Very alarming situations for all of us. Then major challenges for Indian agriculture are marginal land holdings. Already I have discussed. Fragmented land holdings or marginal land holdings. There is a disparity between irrigated yield and the rainfed yield. Definitely there is a high yield in irrigated area and less yield in rainfed area. Because the MSP price has been enhanced by the government. So those areas where irrigation facilities are available, definitely the farmers are being benefited. So degradation, depletion of natural resource base, all of you know, there is a climate change, increase in non-agricultural demand for land and water, the industry, human habitation, all of these are coming up, roads, railways, all of agricultural land is being converted. Inadequate mechanization, labor shortage, inefficient use of inputs, wastage of agricultural produce due to inadequate post-harvest operations. Lack of awareness, ineffective extension mechanism, inefficient financial resources, and high level of consumption services, subsidies, all of you know. What is the disadvantage of providing subsidies? So what is our vision by 2050? We have to reach 400 million tons of food grains. Now, we are at 350 million tons of food grain right now. We can reach this. But regarding fruits and vegetables, 650 million is requirement for fruit and vegetables. So what should be our approach? We must convert level of farming to commercial level of farming. Input intensive to input response is very important. Farmers are how much quantity of nitrogen, phosphorus, and potash. Do you know all these farmers are aware? No. So input intensive, they go on applying these chemical fertilizers, insecticides, pesticides. Directly they are polluting the environment. And over that, there is a pressure of climate change. Input responsive. How much? What soil? There's KPK, there is a soil testing laboratory. They have to think of this, what nutrients present in the soil. Accordingly, they have to calculate how much nutrients required for this particular crop. Carbon negative to carbon positive. That is very important. Global warming, there is a high amount of atmospheric carbon dioxide. How to reduce it, how to minimize it. That should be the approach. Low efficiency to high efficiency. So how to increase the efficiency of the farmer so that the productivity has to be increased. Next, polluting to pollution free. We are applying these insecticides, pesticides, herbicides, all these chemical fertilizers, all these chemical. So suppose a person is going for organic farming and he is cultivating or he is practicing this organic farming to this crop field where these insecticides, pesticides, herbicides have been applied. Now, when this water is being drained out from his plot to the neighboring plot where the farmer is practicing organic farming, that is again being polluted. So we have to think of pollution free. Smart agriculture, all of you know. Climate smart agriculture, most important is conservation techniques. How to retain water, water retention capacity, afforestation. We have to change, we have to see how deforestation climate smart agriculture. So agriculture now is not a farmer's job, rather it is an agribusiness mode. Okay? Do you think farmers are not educated, not intelligent, not attentive, not skilled? They are very eager to learn new things. They are practicing age-old practices. Just we have to change their attitude. We have to supplement what best practices, best methodologies are available. When we talk of livestock industry, that is strength, weakness, opportunity, and threat. As I told you, it contributes 1/4 of this agricultural GDP. Very important sector. Very, very important sector. We have a large livestock population. Opportunities, a poor farmer or a small marginal farmer, a landless laborer, managing 1 or 2, they have the infrastructure facilities. They can be encouraged to manage 4 animals, 6 animals, like this. That is opportunity. Next, most important is we are the smallest, we are the biggest. This is very interesting. What is the meaning of we are the smallest and we are the biggest? Just to see, whenever we talk of a smallest in the world in per capita meals animal holding, just to see, a farmer is keeping only 2 animals, 3 animals, 4 animals, very small numbers. In spite of that, we are the number 1 in the world in total milk production point of view, largest milk producer. Even if the animal holdings are is very less, still population, cattle population, we have reached the #1 position in total milk production. So these animals, when the farmer is keeping 2 animals, they can be encouraged. It is not difficult to manage. Then she or he manage another 2 animals. Next, most important is modern agriculture. One is time, another is space. Because already I have discussed, we do not have more space for horizontal expansion. We have the limited land area. So whatever cropping pattern, whatever cropping intensity is there, we have to increase it. So what times cropping intensity? That is what called as a time concept. When a farmer is growing one crop, allowing the land to remain fallow for 8 months, 4 months, 6 months, he doesn't have an idea to go for a second crop. So present cropping intensity in our country is 155%. We have up to 400% if possible, where there is no constraint for inputs, including irrigation. So this is another way, the alternative, because there is no time left. We have to think of this huge human population growing just like an explosion. We have to meet their feed requirement. So this one concept has to be taken care of. Second one is the space concept. As the horizontal expansion, because there is this area, so alternative is left with us vertical expansion. So we have to think of this modern vertical farming. Where there is in the rainfed area, there is no scope for increasing cropping intensity, space concept can be applied. So multi-tier system of farming. This is our rice-based integrated farming system where we have to take livestock. You can take chicken, we can take duck and fisheries. Both are these compatible enterprises. Fish and duck, along with the rice. Why? There is increase. If this is sustainable. Two enterprises, they will come to the rescue of the farmer. So here there is no waste. All these waste are being utilized properly. The fecal droppings from the duck or chicken are applied on the fish pond to increase the fertility level of the fish pond, so that there will be growing of abundant fish aquatic feeds like zooplankton, phytoplankton, and fishes will grow on those. So there is no supplementary feeding for the fishes. There is no extra expenditure for the fishes. So there is increase in productivity, increase in income, and sustainability will be maintained. There is no waste at all in this system. So this is a holistic approach. Now these are the reasons why we have to go for rice-based integrated farming system along with a duck or poultry or chicken, along with a fish. So improved nutritional security. So qualitative nutrition. We are thinking we'll get qualitative nutritional security, increased income and livelihood security, addressing environmental changes, and relevance to Eastern India. We are vast coastal land. It is the predominant crop grown in this Eastern India. We have a lot of water bodies. So we can think of this model with the eastern part of our country. Now, what I was discussing, the rice, this monocropping, objective is rice-based integrated farming system. What is the problem with the monocropping? Just see, 114 countries, 150 million hectares, 90% Asian countries by small and so intensification of monoculture will harm soil physiochemical parameter, loss of biochemicals, degradation of natural resource, loss of biodiversity. So this is not at all a sustainable way of farming. So different rice-based farming system, part intercropping system, live crop-based system, rice, fish, livestock integrated farming system. So rice, fish, livestock is the better as fulfills the objective, rational utility. Provide rice, duck and fishery. So this is medium deep to deep water lowland is required so that water body, the water table can be maintained till 1 year of a period. This should be free from heavy flooding. Clay soil is required for retention of capacity. We have to think of a rectangular or square field. Then we have to go for a construction of a pond. That should be 5% of the area. Pond and water bodies should be 10% of the area, and the rice field should be 85% of the area. Then what dogs are available? Indian runner, khaki camel, white Pekin, indigenous local stocks. As you know, 250 numbers of dogs sufficient to void their excreta to increase the soil fertility level of 1 hectare of land. So if you are planning for 1 hectare of land, then go for 250 numbers of dogs so that they will increase the soil fertility of that pond area, by which we can 7,500 fish fingerlings of opposite pisciculture. I will come next slide. I will come. Night shelter is forage in the rice during the daytimes. Dog will thrive on the weeds available. Additionally, we can have some supplementary feed, that is a rice bran, which will be obtained from our rice crop. They will maintain their additional feed requirement. Then what are the fish? Composite pisciculture. We have 6 fish species. One is katla, second is silver carp, fourth one, fifth one common carp, another is grass carp. So we have to take combinedly all these 6 species of fish. The reason being behind is that some of these fishes are surface feeder, some of the fishes are column feeder, some of the fishes are bottom feeder. So the entire nutrients available in that water body, maybe pond or any water body, entire feeds available can be effectively utilized by all these 6 species of fish. Okay. Then, as I was telling, 7,500 numbers of we have fishes at the fingerling stage. At the fry stage, because it's very small, dogs can feed on those fries. But dogs cannot feed. So in the ratio of 40, 20, 30, and 10 as a surface feeder, column feeder, bottom feeder, and grass feeder. In addition to these 6 species of freshwater fish, we can also go for a prawn. 2 different species of prawn can be released at the rate of 2 to 4 numbers per square meter area. Microbrachium rosenbergi and another is Microbrachium malcolmsoni. This is the schematic diagram of integrated rice, fish, and dog farming. The green area is a rice field, and at the adjacent to this green, this is water body, where these fishes and dogs, they have to be maintained. Mechanism is a symbiotic relationship. Dogs and fishes control the harmful insects and weeds that could have been detrimental for a rice crop, and their droppings act as an organic manure. And by churning and scooping of this, release the nutrients available in the fish pond for fishes and growth of these phytoplanktons and zooplanktons. So this is the nutrient cycle. The excreta of the fish acts as a fertilizer, excreta of the dog acts as a fertilizer for, and simultaneously the adjacent rice field will get sufficient quantity of that organic way of manure from to horses and dogs for their better growth and better nutritional quality. This is how this nitrogen fixation and methane by this cycle methagenesis activity. The next is impact analysis, energy footprint and efficiency. More rice, fish, duck system of farming having more energy efficient. Why more energy efficient? When we talk over more energy efficient, we talk about renewable energy, and we talk about non-renewable energy. So rice, fish, and duck system of farming utilizes more amount of renewable energy, which is advantageous. 70.62% of renewable energy, whereas only 29% non-renewable energy. Reversely, monocropping system, rice monocropping, they utilizes less renewable energy, more non-renewable energy. So IFS, integrated farming system, rice, fish, duckery system is more energy efficient as compared to conventional rice farming. Then another most important, water productivity in conventional rice farming and integrated farming system. What is the meaning of water productivity? How much quantity of biomass, how much quantity of yield, crop yield, biomass yield, whether it's a crop, or whether it's a livestock, whether it's a fish, anything. How much quantity is obtained by per unit water area? So whenever we compare, you just see at conventional farming water productivity 0.390 and the integrated farming system 0.872. Within the parenthesis, this is the times more. Means with less water, more productivity in integrated farming system. So when we convert into the value, monetary value, just see in conventional farming, it gives rupees per cubic meter 5.854, but in IFS it gives 13.310. So 2.2 times more than this conventional farming. Then this in the rice and rice conventional system, there is a production of carbon dioxide 6069 kg per hectare area. But in integrated farming system with the model of a rice, fish, duck, there is 5333 kg carbon dioxide. Then entire integrated system taken together, the emission of methane from the rice, fish system was 34.6% less than that from monoculture rice fields. Then the soil and water quality, definitely in the integrated farming system, we will get dissolved oxygen, nitrate, ammonia, total alkalinity, dissolved organic matter, and compared to non-conventional system. The aquatic biological diversity, including plankton's growth, phytoplankton, zooplankton, soil bathing fauna, microbial population, dynamic and integrated. This gives an idea how soil health is maintained in integrated farming system. These are all benefits of our integrated farming system: economic benefits, environmental benefits, social benefits, reduced dependence on external imports, because nothing is being wasted, everything is being utilized. So we have some challenges in IFS adoption. What challenges? We have declining land. So we have to plan for 1 hectare land, what should we plan? For half acre land, what should we plan? And for 1/4 hectare of land, what should be our plan? Proper system design, development and validation, vast diversity of social and cultural environment, initial and regular investment requires proper credit availability. That's why I was discussing in the farming, what is the definition of farming system? Institutional role. So bankers should come forward to give finance financial benefit to this farming community, credit availability, technically empowered, suitable training and demonstration, extension mechanisms should be thorough enough. This is very important because in the integrated farming system, farmers used to get their produce or product and they often visit market. So we have to establish a market chain. They should not face any difficulties for selling of their produce. And we have to see the security from wild animals and theft. So best practices for IFS implementation, site-specific model selection, capacity building of farmers, efficient resource management, use of ICT for decision making. This is a model developed for a 0.4 hectare or 1 acre of land, considering small and marginal farmers of this area. So what the enterprises have been taken into consideration, crops under cultivation in the locality, those crops have been taken into consideration, crop rotation that is followed, water requirement of the fish pond. So we have taken the three components, cropping, fisheries and poultry. Land allocation is 0.4 hectare, and this has been divided, cropping allotted at 0.36 hectare, fish pond is 0.04 hectare, and the total is 0.40 hectare. Now here is a poultry shed is a vertical integration. We are not acquiring another land area for construction of this poultry house. This poultry house has been constructed over this fish pond. So this is one example of a vertical integration. So this is the cropping pattern throughout the year. Rice, the varieties, maize, what are the crop rotation has been followed, rice, groundnut, rice, maize, rice, sesame. So 0.36 hectare has been divided into 0.16 hectare, 0.10 hectare, and 0.10 hectare. And these are all varieties. Then, as I was discussing, 7,500 fingerlings are required for 1 hectare of pond area. So we have our 0.04 hectare. So it is calculated 300 numbers of fingerlings. Already I have discussed the 6 numbers of species. Their ratio has to be maintained as feeds are available throughout the pond area, water body from surface to bottom. This I am skipping, nutrition recycling for growth of phytoplankton and zooplanktons. This is the different stage of growth of the fish, starting from spawn to fry to fingerling, then to yearling. These are the 6 species of fish. Then we have to take poultry here. Then 500 layer chicks sufficient enough to void their excreta to meet the requirement of 7,500 fingerlings in a hectare pond area. So this is established. So we have taken 0.04 hectare pond area. So accordingly, we have to calculate, and there are 20 layer chicks. The name is Babcock layer chicks are required for this study. Then we have to see is a control. As I was discussing, the monocropping rice, here we have taken crop rotation. Then we have to see the benefit of IFS over control. Here we have calculated in rice cultivation, whatever best managemental practices you can take. You take care of all these best managemental practices, scientific managemental practices with the utmost nutrient application, then weeding, everything. Even INM, integrated nutrient management, even IPM, integrated pest management, whatever technologies are there to apply. Still, you cannot devoid of getting 5 to 7% yield field or partly field grains. That will come. Now, these are not consumer will not prefer these partly filled grains. So these feeds will substitute the poultry feed. So 30% poultry feed can be substituted by these yield filled or partly filled grains. That is directly is a benefit for this integrated farming system. So poultry feed cost can be reduced by about 57.5%. So in the mortality of birds was almost nil till the end of the program. Now let us see the economics. So here is the cost of production per egg is around 42 to 44 pies in commercial scale of production. By this integrated farming system, cost of production per egg is reduced to 19 pies. Okay. So we do not have applied anything to this fish pond except this poultry excreta. So whatever fish is obtained at that marketable age, let it be 1 kg per fish. So 250 to 300 kg per year, which is marketing is a bonus. The farmer has not invested except purchasing of fingerlings. Farmers has not invested anything for this maintenance of fishes. These are the nutritive value of poultry menu. So this is the economics for all the 5 years. So from integrated farming system, this was way back, this was calculated. So 34,000 per hectare per year. In contrast to conventional system, 17,586 per hectare per year. The net profit was 93.33 per hectare per day. And there is employment generation of 102% in main days over the conventional system. So now let me share my experiences where I have worked more than 16 years in different researches and different KVKs. It may help you when you will formulate your programs in KVKs or research stations or even if in teaching. So way back in 1998, this is one thing. One of our DDG at that time, Deputy Director General Extension, he came over to Jivdegiri. Before that, my Dean Extension asked me, can you have some animal science programs so that DDG can have a look, have a visit? So I thought that that area was deprived of electricity. But our undergraduate career, we have been taught electricity is required for rearing of broiler birds, commercial broiler birds. While electricity is required, it will provide light and it will provide artificial heat for this artificial brooding. So I thought, if the electricity is not available, can I ask a farmer to take up this broiler farming in absence of electricity? So in the help of a kerosene lantern, which helped in providing light, and this coal chula, which provides heat for this brooding of, and this was a quite successful program. Next is in KVK Moiribhanj, I got a project from NABARD to establish a broader grower unit poultry house, because these farmers, you can see these lady farmers, they are very fond of rearing poultry in their backyard system. So Moiribhanj is dominated by tribal community. They used to rear these poultry birds. So I thought, let us take this LIT, low input technology birds. Bonaraja is one of among them. So I brought this Bonaraja chicks, day-old chicks, 1,500 Bonaraja day-old chicks from our Central Poultry Development Organization every month. I used to take them, I used to rear them up to 21 days. After getting vaccinated all those birds, I used to hand over those birds to women self-help group. Moiribhanj is a very vast district, undivided district, having 26 blocks. All these women farmers, women self-help group farmers were supplied with these Bonaraja 21-day chicks to them. And this was a quite successful program during my stay at KVK Samakota, Moiribhanj. This is one program. This is my agriculture friends, they can understand. This is a frontline demonstration on elephant photium, Gajendra, that was being conducted at KVK Baleswar, and that was a record yield. Throughout the Odisha. Our foundation day. Thereby our he was given the components: rice, banana, pisciculture, poultry, and dairy. And you can see all these expenditure statement, and the benefit cost ratio was 1.82, and the maximum benefit is being contributed from the dairy animals. And this is the farmer Gaurahari Mahanto of that village. This is the schematic diagram. What are the areas being distributed among the different components? Rice 8%, banana 6%, pisciculture 23%, poultry 3%, and dairy component 60%. This is his model, farming system components of Moribhans. Thank you. If any questions, I will be glad.
Sure, sir. Thank you a lot. So the session is now open for question. Any participant having any queries regarding rice-based integrated farming system can directly ask, sir. Please, any participant, please.